Uh, Hello, folks. Today I'm gonna continue to learn Rust, and it's been a little time since I recorded my last session. So I'm about to review the last session. Uh, in chapter 2, in the second chapter, I finished the guessing game creation project, and I check the behavior. Yeah, cargo run and guess the number. Please input your guess, and 30 and too big, 10, too big, 8, what? Too big, 2, too small, 4, 5, 6, 7, you win. Okay, I won. So that's okay. And let's review the program. Open the editor, and what what what's that? Oh, it is. And name it RS. Yeah, this is a few a very short example for guessing game, and this is run crate. Crate is kind of library, and it uh, enables me to generate random numbers by using these kind of functions, and also ordering, yeah, this, and stdio. Std may probably stand for standard template library, not SL. STD, standard library. Yeah. Oh, this. Yeah. And this is the main function, and this is the entry point of the program, like C, C++, and other languages. And print ln with exclamation mark. This is called uh, macro. Oh, typo. Macro, not a function, but according to the book, macro is a little like a function. Macros like functions, but I don't know what's the difference between these. Right, just recognize this is a macro, and let secret number equals round rng blah blah blah. So generates a random number uh, with the range of from 1 to 100, so including 100 because this is equal operator, and this variable is immutable by default. So I couldn't overwrite the variable like this. Cannot mutate immutable variable, blah blah blah. So this is not allowed. If I want to do that, I have to put mut keyword. Mut stands for mutable, Yeah. So variables declared with let are immutable by default. This is a very interesting, yeah, feature in Rust. And also loop statement expression. I don't know. Loop is a different expression. Yeah, this is kind of this is like a while true or while one, but yeah, Rust may have while keyword, and also yeah, needless to say for, but still has loop statement. I'm not sure what this means, right? But I will get aware of the fact one day, yeah. And this is infinite loop, and print n, please input your guess and let mod guess. So the string is mutable, yeah. And wait for the user input via stdin method and dot line dot read line, and uh, capture the input and put it into this, yeah, this variable. And also if the input is invalid, or yeah, kind of something bad input, this is kind of easy error handling, yeah. And also shadowing is this shadowing, yeah. I barely remember. Shadowing is just, yeah, declare variable with the same name previously declared, yeah, this. And so like this simply change the type of uh, the variable, right? So this is this probably, yeah, string type, but in this part I try to convert the type of the variable from string to U32 unsigned in 32 bits maybe. And match statement, and a match is I guess match is the counterpart of uh, switch statement in other languages, maybe. But that seems more powerful. And match statement, a match statement expression. I should say it's I should call it as, yeah, expression, because uh, it returns result type, yeah. So like okay and error, and so capture the output and none, okay, none, error, continue. Like this seems like uh, catch dot three dot in C++ or something, yeah. And you guessed, and so capture input, take the input, and so convert the type and print the message and compare the number captured and also the other number kind of generated via round method. And again, I use match to and compare these numbers because user input it just turned into a number because of that, because of this, yeah. And if secret number is larger, larger than my input, yeah, too small, and the secret number is less than my input is too big. And when I enter the same number to the secret number, I win. Okay, so I already executed the program, so but again I'm about to run it. What? Oh, sorry. 40, 50, 80, 70, 74, 72 big, 72. I just won. Yeah. Okay. And yeah, I just commit. So I just reviewed the previous session and I'm gonna go dive into the main concept of Rust. Yeah, the very basic fundamental concept of Rust. I can see variables, mutability, data type functions, comments, control flow, like so if or switch a match statement or something like that. Oh, I'm just thinking, when a function returns a value or values, I should call it expression rather than statement. Yeah, so Rust is basically, yeah, a functional language. So kind of like, so I should call like, so if expression loop expression maybe a match expression. Yeah. Mm, yeah, actually I'm sure. I'm drinking orange juice. I need to hydrate myself. Yeah. So yeah, so let's go. But hello cargo. So I add programs. In the file. Okay. So yeah, actually, so I uploaded a video maybe 4 days ago. Yeah, 4 days ago. Uh, but I actually I today I just finished yeah, university exams, and so yeah, I I took tests 4 days straight, and yeah, I was very tired of preparing for these exams. Yeah, but anyway, so I finished that, and let's check what and cargo check. Uh, what is cargo check? Cargo checks the dependency of the project. Maybe like cargo build. Yeah, I can build that. Yeah. And common programming concepts. This chapter covers concepts that appear in almost every programming language. Yeah, and how they work in Rust. Many programming languages have much in common at their core. None of the concepts presented in this chapter are unique to Rust, but we'll discuss them in the context of Rust and explain the conventions around using these concepts. Specifically, you'll learn about variables, basic types, functions, comments, and control flow. These foundations will be in every Rust program, and learning them early will give you a strong core to start from. Yeah, and these concepts, right? So types, functions, control flow, and so on. When it comes to that, almost every programming language have has these concepts uh, to implement algorithms, and I already know how to write functions in a very easy way, like looks similar to C. Yeah, though the return type uh, isn't yeah, written in this part. Like in C, uh, void or right, so int main return 0. Yeah, like this. And keywords, and the Rust language has a set of keywords that are reserved. So yeah, so this means yeah, reserved words probably that are reserved for use by the language only, much as in other languages. Yeah, right. So main or kind of if, kind of maybe if match, blah blah blah. Mostly Korean special names. So yeah, okay. And I already know that. And I'm about to learn about variables and mutability. Yeah. As mentioned, as mentioned in the storing values with variables section, by default, variables are immutable. Yeah, as I said. In the review part. Yeah, this is mutable and immutable by default. Yeah, so this is immutable. And this is one of many nudges. sorry, what is nudges? Sorry, light touch or push. Okay. Many nudges Rust gives you to write your code in a way that takes advantage of the safety and easy concurrency that Rust offers. So it seems like, yeah, Rust, yeah, seems to focus on concurrency and safety and speed. Yeah. However, you still have the option to make your variables mutable. Yeah, I have an option. Let's explore how and why Rust encourages you to favor immutability and why sometimes you might want to opt out. Yeah. Uh, so by default, variables are immutable. Yeah, this is this is very interesting. Yeah, I I continuously say that, but like so, considering or like kind of talking about JavaScript, we declare variables like this, and these were without semicolon. Let x equals 5 or something. Uh, and this is this is just a variable. So I can overwrite the variable like this, and even like this, because JavaScript is a type of uh, not strictly typed languages. Like so. What? How how should I call it? Not strictly, but kind of roughly typed. A dynamically typed, yeah, a dynamically typed language, yeah. So, and also I can use const declaration. I couldn't overwrite the variable because, yeah, apparently y is a constant. Yeah, like so, final in Java or yeah, in so C++ also has const keyword and so on. But Rust is very kind of unique. So as I said, in JavaScript, let x equals 5. This is not immutable, and usually, almost all languages except for Rust uh, adopts this type of declaration. Yeah, as far as I know. But Rust is very unique and kind of modern way to implement that. So even in JavaScript, yeah, people prefer to use const in some situations because of the safety and yeah, just readability and so on. Now let's go. And when a variable is immutable, once a variable is bound to a name, you can't change that value. To illustrate this, generate a new project called variables in your project directory by using cargo new variables. Okay, so I will create a new project, cargo new, and yeah, this is hello world, and test okay, hello world, and then in your new variables directory, open sh main, yeah, and replace its code with the foreign code which won't compile just yet. Yeah, let x equals 5. This is immutable. And println, this is a macro. The value of x is x. This is a placeholder. Yeah, x equals 6. So this is not allowed. So the compiler will scold me. Of x is so yeah, kind of mutate immutable variable. And I try to build the project, but I have error. Cannot assign twice to immutable variable x. Yeah, this is the first time declaration, and I tried to overwrite the variable, but x is immutable by default, so I have to put mut keyword in this part, and I successfully built. And cargo run, the value of x is 5, yeah, and the value of x is 6, yeah. And what? Target. Uh, target. Cargo. Git ignore. Okay, I will just add log domain address. Yeah. And let's continue. Save and run the program using command run. You should receive an error message regarding an immutability error, as shown in this output. Comparing variables per error cannot assign twice to immutable variable. Yeah, we already seen that. This example shows how the compiler helps you find errors in your programs. Compiler errors can be frustrating. Yeah, that's very frustrating. But really, they only mean your program isn't safely doing what you want it to do yet. What? Sorry, I couldn't understand. They only mean your program isn't safely doing what you want it to do yet. Oh, okay. They don't mean that you are not a good programmer. Experienced Rustaceans. Oh, Rustaceans is like a crustaceans. Yeah. Okay. I still get compiler errors. You received the error message can't assign twice to immutable variable x. Because you try to assign a second value to the immutable x variable. And I just thought, oh, sorry, my keyboard my keyboard was almost broken. Sorry. Okay. And I'm just curious about uh, the difference between immutability, and consent. Yeah, so constant is but Rust does Rust have const? Yeah, there's const keyword. Compile time constants. Okay. I shouldn't drop by that. And it's important that we get compile time errors when we attempt to change a value that is designated or as immutable, because this very situation can lead to bugs. If one part of our code operates on the assumption that a value will never change and another part of our code changes that value, it's possible that the first part of the code won't do what it was designed to do. The cause of this kind of bug can be difficult to track down after the fact, especially when the second piece of code changes the value only sometimes. Uh, changes, when the second piece of code changes the value only sometimes. Also, this kind of bug can be difficult to track down after the fact, especially. Okay, the Rust compiler guarantees that when you state that a value won't change, it really won't change. So you don't have to keep track of it yourself. Your code is thus easier to reason through. But mutability can be very useful and it can make code more convenient to write, although variables are mutable. by default. You can make them mutable by adding mut in front of the variable name, as you did in chapter 2. Adding mut also conveys intent to future readers of the code by indicating that other parts of the code will be changing this variable's value. Yeah. For example, let's change this assuming rs to foreign. Yeah, like this. When we run the program, now we get this. Oh, I will run. Yes. We are allowed to change the value bound x from 5 to 6, 5 to 6. When mut is used, ultimately deciding whether to use mutability or not is up to you and depends on what you think is clearest in that particular situation. Yes, constant like immutable variables. Constants are values that are bound to a name and are not allowed to change. Okay, not allowed to change. But there are a few differences between constant and variable. A few differences, okay. First, you aren't allowed to use mut with constants. Okay, so const should be immutable all the time, I guess. Constants aren't just immutable by default. They're always immutable. Yeah, as I said. You declare constants using the const keyword instead of the let keyword. Yeah, and the type of the value must be annotated. Yeah. Oh, must be annotated. So I have to specify the type of the variable. Maybe we'll cover types and type annotations in the next section. Okay, I'm very excited. So don't worry about the details right now. Just know that you must always annotate the type. Okay, constants can be declared in any scope, including the global scope, which makes them useful for values that many parts of code need to know about. The last difference is that constants may be set only to a constant expression. What? Not the result of a value that could only be computed at runtime. Here's an example of a constant declaration. Count 3 hours in seconds. 60 times 60 times 3. The constant's name is 3 hours in seconds and its value is set to the result of multiplying 60, the number of seconds in a minute, by 60 by 3. Rust naming convention for constant is to use all uppercase with underscores between words. Right? Yeah, like kind of upper snake case, kind of. And this convention is, yeah, exists in other programming languages, I know. The compiler is able to evaluate a limited set of operations at compile time, which lets us choose to write out this value in a way that's easier to understand and verify, rather than setting this constant to the value 10,800. See the Rust references section to the constant evaluation for more information on what operations can be used when declaring constants. Constants are valid for the entire time a program runs within the scope in which they were declared. This property makes constant useful for variables in your application domain that multiple parts of the program might need to know about, such as the maximum number of points any player of a game is allowed to earn, or the speed of light. Constant. Okay, yeah, I get it. Naming hard-coded values used throughout your program as constants is useful in conveying the meaning of that value to future maintainers of the code. So not just a syntax, but for uh, to bind the behavior of variables, but also it is for readability, a kind of marker for other developers. It also helps to have only one place in your code you would need a change if the hard-coded value needed to be updated in the future. Yeah, shadowing. Oh, as you saw in the guessing game tutorial in chapter 2, you can declare a new variable with the same name as a previous variable. Rustasians say that the first variable is shadowed by a second. Shadowed, yeah. Which means that the second variable is what the compiler will see when you use the name of the variable. In effect, the second variable overshadows the first, taking any uses of the variable name to itself until either it itself is shadowed or the scope ends. We can shadow a variable by using the same variable's name and repeating the use of the let keyword as follows. Only let keyword allows me to shadow. I'm not sure. If a main let x equals 5, let x equals so increment, and this is our scope, and let x equals x times 2, so 2x. The value of x in the inner scope is 1 increment 6 and 2x, so 12, and the value of x is 6. Yeah, this value is only varied in the scope, and this macro is situated in is the outside of the scope, so the last value is 6, so the value of x is 6. Yeah. The program first binds x to a value of 5, then it creates a new variable x by repeating let x equals, taking the original value and adding 1 to the value of x is then 6. And that rest have increment. Okay. Rust doesn't have increment operator. Oh, yeah. And then within an inner scope created with the curly braces, the third let statement also shadows x. It shadows x. What? Should I use shadowing? Let. What? What? This is allowed. 5, 6. Oh, okay. So I don't need to put mod keyword, so that means I don't need to make the first declaration with immutability. Yeah. Okay. So I may or may not sh use shadowing. Oh yeah. When the scope is over, the inner shadowing ends and X returns to being 6. When we run this program, it will output the following cargo run. Shadowing is different from making a variable as mod because we'll get a compile time error if we accidentally try to reassign to this variable without using the let keyword. By using let, we can perform a few transmissions on a variable, but have a variable be immutable after those transmissions have been completed. The other difference between mod and shadowing is that because we are effectively creating a new variable when we use the let keyword again, we can change the type of the variable but reuse the same name, recycle. For example, say our program asks our user to show how many spaces they want between some text by inputting space characters, and then we want to store that input as a number. Yes, the first spaces variable is a string type, right? So, okay, and the second spaces variable is a number type, obviously. The shadowing that spares us from having to come up with different names such as spaces, str. Oh, so we use the same name. Okay. And spaces num instead we can reuse the simpler spaces name. However, if we try to use mod for this, as shown here, we'll get a compile time error. Let mod spaces equals blah, blah. So this is not the type indifference there. Maybe the Rust is compiler-based language, not a interpreter language. So uh, sorry, that was a little wrong, and I should say Rust is not dynamically typed, so I couldn't do this operation. The error says we are not allowed to mutate a variable's type. Cargo run comparing variables were mismatched types. Yeah, exactly. Expected and is there found use size. Now that we've explored how variables work, let's look at more data types that they can have. So, okay. So in general, I should use this approach. I should take this approach, yeah, instead of just make X mutable. maybe even the Rust has the feature that I should prefer to use shadowing over making the method the way to make variables mutable. And then in the next section, yeah, data types. Every variant in Rust is of a certain data type, which tells Rust what kind of data is being specified, so it knows how to work with that data. We'll look at two data types such as scalar and compound. Keep in mind that Rust is a statically typed language, not dynamically typed, which means that it must know the types of all variables at compile time. The compiler can usually infer what type we want to use based on the value and how we use it. In cases when many types are possible, such as when we converted the string to a numeric type using parse, like this, the parse, yeah, and we must add a type annotation like this. Let's guess user2. This is type annotation. So I think I can save the part usually. Yeah, so in C language, like so we type like this, but Rust only I should write this, but let is not a type. Int is a type, right? So I can double or float or char, but Rust only has let constant blah 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 keywords. This is not a type. This doesn't indicate the type of the variable. Alright, so I guess the Rust compiler assumes or kind of infers the type uh, based on the right part, like so C++ the auto keyword like this. But when I use parse method, I have to put the annotation maybe. If we don't add the user2 type annotation showing the preceding code, Rust will display the following error, which means the compiler needs more information from us to know which type we want to use. Type annotations needed. The Rust compiler is very kind of so how should I say? Uh, that's kind of yeah very yeah like a very kind teacher or something. Yeah, very kind. Very helpful. So based on that, so when I convert the type of a variable by using shadowing. I should use parse method, and I have to annotate the type which I aim for, maybe. And scalar types, and scalar type represents a single value. Rust has four primary scalar types: integers, floating point numbers, booleans, and characters. Okay. You may recognize these from other programming languages. Yeah, I know. Now let's jump into how they work in Rust. Integer types. An integer is a number without a fractional component. Yeah, we used one integer type in chapter 2 that use already to type. The type declaration indicates that that value is associated with should be an unsigned integer. Signed integer type start with I instead of U. Just like so, U int 8 T or something like that in C, C++, and so on. That takes yeah, yeah, and I often use some microcontrollers and I tend to touch embedded systems, so I often use these kind of keywords. And what? And that takes up 32 bits of space. Usually int is 32 bits. And table star 3.1 shows the built-in integer types in Rust. We can use any of these variants to declare the type of an integer value. Usually, I assume I will use U32, I32, yeah. Each variant can be either signed or unsigned and has an explicit size. Signed and unsigned refer to whether it's possible for the number to be negative. In other words, whether the number needs to have a sign with it, signed, or whether it only ever be positive and can therefore be represented without sign. It's like writing numbers on paper. When the sign matters, a number is shown with a plus sign or a minus sign. However, when it's safe to assume the number is positive, it's shown with no sign. Signed numbers are stored using two's complement. Yeah, yeah, yeah. I know this. Two's complement representation. So like so, two minus something. Yeah. To represent negative numbers. And each signed variant can store numbers from minus to oh what how can I beat this so exponential things? Two powered by maybe a power 2 minus 2 powered by n minus 1 to 2 powered by n minus 1 minus 1 inclusive, and the number of bits that variant uses. So I8 can store numbers from blah blah blah. Yes, so I know this, so I skipped the part. I'm showing the I size and U size time depending on the architecture the computer your program is running on. If 64 bits if you are on a 64-bit architecture and 32 bits if you are on a 32-bit architecture. Yeah, kind of so size T or something. You can write integer letters in any of the fonts shown in table 32. Note that the number letters that can be multiple numeric types allow type suffix. Allow, so not necessary. maybe to designate the type. The number letters can also use as a visual separator to make the number easier to read, such as 1000, which will have the same value as if you had this value 1000. Easier to read, yes, for readability. Okay. Decimal hex, so hexadecimal number, and octal, binary, byte, okay. So how do you know which type of integer to use? If you are unsure, Rust defaults are generally good places to start. Integer types defaults to I32. So this is I32. The size or something? Size type size of what you can escape it. Escape. What what? Oh, okay. Oh. Type size. It comments size. Um. I'm sure where we'll know the method. Let's check the type. Rust. Check the type. What? Print type. Oh, that's good. Type any std any type name function. Yeah. Type name T. This is like a template in C++, right? So generics or something in other languages, maybe. I don't know. Type name T. Okay, and I use it. So this traces placeholder, and I use the function macro. I don't know. Or maybe I use the function. What? Doesn't implement, is not implemented for what? 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 What is that? Type name T. Let's so also I should maybe okay, congruent. So type name is I32. So as I said, the default integer type is I32. Yeah, maybe. Rust defaults are generally good places to start. Integer types default to I32. Yes. Integer overflow. Let's say you have a variable of the type UA that can hold variable between 0 and 255. If you try to change the variable to a variable outside of the range, such as to a variable, I passed the section. Floating point types. Floating point. Rust also has two primitive types. So primitive types is like a int, integer, floating point, and boolean, and what? What? Numbers. Number. Oh, what? Numbers. Integers, floating point. Sorry. Integers, floating point numbers, booleans, and characters. Okay. And floating point numbers. F32 and F64. Yeah, the default type is F64. And so 5.0 and check the type. What? What? Oh, sorry. What? 1.0. Okay. The type is F64. So default type maybe 64 in my architecture. The default type is F64. Yeah, like this. Because on modern CPUs, it's roughly the same speed as F32, but it's capable of more precision. All floating point types are signed. Yeah. Here's an example that shows floating point numbers in action. If the main let x equals 2.0 F64, and I explicitly annotates the type and check it, and F32. Okay. And floating point numbers are represented according to the IEEE 754 standard. Numeric operations. Rust supports the basic mathematical operations you'd expect for all the number types: addition, subtraction, multiplication, division, and remainder. Integer division truncates toward 0 to the nearest integer. The following code shows how you'd use each numeric operations in a let statement: addition, subtraction, multiplication, division, truncated. Yeah, okay. And reminder. Okay. Each expression in these statements uses a mathematical operator and evaluates to a single value, which is then bound to a variable appending to blah blah blah. The Boolean type. As in most other programming languages, Boolean type in Rust has two possible values, true and false. So small t, yeah, not like Python's true, false. Booleans are 1 byte in size, 1 byte, okay? The Boolean type in Rust is specified using bool, for example. Okay, let's check it. let t equals true, print type. Okay, and the type name is bool. The main way to use Boolean varies through conditionals, right? So if expression, not a statement. Okay, so I think that means if expression can return values, maybe. And so if expression, we will cover how if expression work in Rust in the control flow section. The character type, char. Rust char type is the language's most primitive alphabetic type. Here are some examples of declaring char values. Yeah, is explicit type annotation char. X a char, that name is char. Okay, the default one character. Now that we specify char letters with single quotes, yeah, not double quotes like this. Yeah, this is almost the same in C, char in C. And as opposed to string letters, which is double quotes, Rust char type is 4 bytes in size and represents a Unicode scalar value, which means it can represent a lot more than just ASCII, accented letter, Chinese, Japanese, and Korean characters. So can I put yeah, so this is Japanese character. This is the first character in Japanese. A char, okay. Emoji and zero with spaces are all varied. Zero with spaces. Zero with spaces. What? Zero with. So. Okay. Clinical skill values range from blah blah blah. However, character isn't really a concept in Unicode, so the human intuition for what a character is may not match up with what a char is in Rust. Okay, okay. Compound types, what? Compound types. Compound types can group multiple values into one type. Rust has two primitive compound types, tupled and arrays. The tuple type seems like tuple in Python. A tuple is a general way of grouping together a number of values with a variety of types into one compound type. Tuples have a fixed length. Once declared, they can grow or shrink in size. So so very static. Yeah, the tuple is static. We create a tuple by writing a comma separated list of values inside parentheses. Each position in the tuple has a type. Yes, and map like this. And the types of the different values in the tuple don't have to be the same. Don't have to be the same. Okay. In this case, these three types are all different. We've added optional type annotations in this example. Okay. Tuple. So, sorry. I32 F64 and U8 equals and 500 integer and 6.4 floating numbers and also 1 with semicolon and TUP tuple. Yeah. And type name Must I put the implicit annotation? Oh, this is not necessary. And this print type function as a guest, not guest, and just showed these variables types like i32, x64, and i32. This is the default types provided by the Rust compiler. Finally searching RS. Okay. The value of y is y. Well, top binds to the interior tuple because the tuple is considered a single compound element. Okay, to get the individual values out of the tuple, again it's pattern matching to destructure a tuple value like this. What? Oh, okay. This as x stores the first element and y stores the second element 6.4, maybe. This program first creates a tuple and binds it to the variable tup. It then uses a pattern is let to take tap and turn it into three separate variables x, y, and z. This is called destructuring. Okay, destructuring, because it breaks the single tuple into three parts. Yeah, in modern languages, yeah, I've seen this kind of syntaxes. Yeah. Finally, the program prints the value of y, which is 6.4. Okay, we can also access tuple element directly by using a period. 0.0, 0.1, 0.2, like so, based on the index. Index reference, followed by the index of the value we want to access, for example, 0, 1, 2, yes. This program creates the tuple X and then accesses each element of the tuple using their respective indices. Right, so the plural form of index. Yeah. As with most programming languages, the first index in a tuple is 0, 0, 1, 2. Yeah. The tuple without any values has a special name, unit. Okay, this value and its corresponding type are both written parentheses and represent an empty value or an empty return type. Expressions implicitly return the unit value if they don't return any other value. Okay. Oh, yeah. The array type, another way to have a collection of multiple values is with an array. Unlike a tuple, every element of an array must have the same type. Yeah. Unlike arrays in some other languages, arrays in Rust have a fixed length. So static array. So there should exist vectors or kind of dynamic arrays. Yeah, so instead of using these kind of things, you write the values in an array as a comma-separated list inside square brackets. Arrays are useful when you want your data allocated on the stack, the same as the other types we have seen so far, rather than the heap. Yeah. or when you want but ensure you always have a fixed number of elements. An array isn't as flexible as the vector type. So there's a vector type. A vector is a similar collection type provided by a standard library that is allowed to grow or shrink in size because its contents live on the heap. Just like C++, the std vector, if you're unsure whether to use an array or a vector, chances are you should use a vector. Okay, chances are you should use a big vector. So I will use vector in almost all cases. Yeah, after all, I guess so. However, arrays are more useful when you know the number of elements will not need to change. For example, if you were using the names of the months in a program, you would probably use an array rather than a vector because you know it'll always contain 12 elements. Yeah, that's right. You write an array type using square brackets with the type of each element, a semicolon, and then the number of elements in the array, like so. Yeah, very intuitive, a very normal syntax compared to other languages. Here, I try to it's a type of each element. After semicolon, the number 5 indicates the array contains 5 elements. So I try to 1, 2, 3, 4, 5, and check the type, and I 32 and 5. So okay. And I can also initialize an array to contain the same variable for each element by specifying the initial variable followed by a semicolon, and then the length of the array in square brackets as shown here. Okay. The array named A will contain 5 elements that will always set to the variable 3 initially. This is the same as writing let x equals 3 3, but in a more concise way. Yeah. Accessing array elements. An array is a single chunk of memory of a known fixed size that can be allocated on the stack. You can access elements of an array using indexing like this. Yeah. In this example, the variable named first will get the variable 1. Yeah. Because index 0 indicates the first element of an array, and 1 is the second part, so 2. The second is second, yeah, 2. Because that is a variable at index 0 in the array. The variable named second will get the variable 2 from index 1 in the array. Yeah. A valid array element access. Yeah, let's see what happens if you try to access an element of an array that is past the end of the array. So you run this code similar to the guessing game in chapter 2 to get an array index from the user. 1, 2, 3, 4, 5, please enter an array index. Let mod index equals a string new, and so create a string type variable, and to std and blah blah blah, and to wait and to capture store the user input into in the index variable, and let index go shadowing. This is shadowing, and use size equals index string parse expect, and string to use size converting the type, and also let element equals a index. So the value of the element of the index is so based on the user input. When a user input a varied index, this program will return the element with the index in the A array. Yeah. This code compiles successfully if you run this code using cargo run. So I'll copy and paste it. Oh, okay. And cargo run. Please enter an array index and 0, and the element is 1, and also I will enter 4, and I expect 5 as the output. 4 and 5, okay. And this code compiles successfully if you run this code using cargo run and enter blah blah blah, and the program will print out the corresponding value at that index in the array. If you instead enter a number past the end of the array, such as 10, you will see the output like this, like so. And I try to access the 11th element of the array A, but the length of the array is just 5, so out of bounds the length is 5 but the index is 10 plus factories 1 environment variable with 5 factories. So the length of the array is 5 but the index I try to access is 10. Okay. The program resulted in a runtime error. Yeah, runtime error, not a compile time error. It's a runtime. Cargo build. There's no errors at the time at this time. But when I try to execute the program and input the invalid number index, and the program gave me this error. And the point using the invalid category. The program exited with an error message and didn't execute the final println. So the error was occurred in 9, also the previous 19th line, so this part. So runtime error can happen, so there's no printed output about this line. This line didn't be executed because the code was crashing in the part. Okay, so the program exited with an error message and didn't execute the final println statement. When you attempt to access an element using indexing, Rust will check that the index you specified is less than the array length. If the index is greater than or equal to the length, Rust will panic. This check has to happen at runtime, especially in this case, because the compiler can't possibly know what value a user will enter when they run the code later. Okay, so the error handling must be implemented actually, and this is an example of Rust memory safety principles in action. In many low-level languages, this kind of check is not done. like so C. And when you provide an incorrect index, invalid memory can be accessed. Rust protects you against this kind of error by immediately exiting instead of allowing the memory access and continuing. Chapter 9 discusses more of Rust error handling and how you can write readable, safe code that neither panics nor allows invalid memory access. Okay? Today, that's kind of a little long. Okay, so I'll speed up. Functions are prevalent in Rust code. You've already seen one of the most important functions in the language, the main function. This is the entry point, and which is the entry point of many programs. Yeah, I just said. You've also seen the FN keyword. So obviously it stands for function. Yeah, which allows you to declare new functions. Rust code uses snake case as a conventional style. Yeah, snake case for the function of variable names in which all letters, lowercase and underscore separate words. Here's a program that contains an example function definition. Another function, this is snake case, and using fn keyword and declare function. Another function. So I main main different another function, and in the print around and hello world. Oh, sorry. Another function, and this call the function, and print around and another function. Then I expect when I run the code, I will see hello world first, and second I will see another function, because this function will be called via this syntax. Then I check it cargo run and hello world and another function. The function was called in this part, and I change the order. The order will be reversed. Okay, as I expected. And we define the function in Rust by entering fn for by function name and a set of parentheses. The curly brackets tell the compiler where the function body begins and ends. Like a block. This is a block. And I can call any function will be defined by entering its name followed by a set of parentheses. Yeah. Usually there are arguments, maybe, because another function is defined in the program. It can be called from inside the main function. Now that we define another function after the main function in the source code, we could have defined it before as well. Rust doesn't care where you define your functions, only that Rust doesn't care where you define your functions. Actually, C language does care about it. Yeah, so that's why people use I I I I I I forgot how I forgot how to say that. Uh, pre no prototype decoration. Yeah, prototype decoration, or just so write write the other functions except for the entry point before writing the main function, or just using header files and so on. But Rust doesn't care that. and only that they are defined somewhere in scope that can be seen by a scalar. Let's start a new binary project named functions to explore functions further. Okay. Cargo new functions. What? Cargo new functions. And yes. I have to gather these projects into one project. Yeah. And the functions. Okay. Alright. Git collection at functions. Okay. When I check cargo run and okay. And the lines execute in the order in which they appear in the main function. First, the hello world message prints, and then another function is called and its message printed. I already have that program in the main arrays. Anyway, we define a function in the rest, blah blah blah, and parentheses. We can define functions to have parameters. Yeah, parameters, which are special variables that are part of function's signature. When a function has parameters, we can provide it with concrete values for those parameters. Technically, the concrete values are called arguments. But in casual conversation, people tend to use the words parameter and argument interchangeably. So, also me, uh, I said arguments are to point out the content which should be placed into the, yeah, so parentheses, kind of. But actually, parameters and arguments maybe, but I tend to use these words interchangeably, and yeah, even yeah, actually even in my native language in Japanese, so we don't distinguish these words maybe. Kisu. Yeah, yeah, yeah. And or either the variables in the function definition of the concrete function will record function. Okay, and in this version of another function, we add a parameter, and x I32 and 5. So when when the function when this function is called, x equals 5, and the value of x is okay, this, and so 5, and pass the 5 to the variable, and in the scope x equals 5, so that's why the variable x is 5 I expect, like that. I check by run the program, and hello world, this line, and also the value of x is 5, and I change the argument and 7, and okay. And try running this one, you should get for output. Okay, the declaration to another function has one parameter named x parameter. The type of x is specified as I32. Like when I put so I64 or just so you if64, and I pass 7.0. What? 7.2. Okay, 0.0 was omitted. And the x is specified with I32. So I32 the default type, and when we pass 5 into another function, the print error macro puts 5 with a pair of characteristics containing x was in format string. In function signatures, you must declare the type of each parameter. Must declare. So I couldn't write like this, but I have to specify the type explicitly. The type mismatch. Yeah, and so this is a deliberate decision. I have a deliberately put this part in requiring type annotations in function definitions means that compiler almost never needs you to use them elsewhere in the code to figure out what type you mean. The compiler is also able to give more helpful error messages if it knows what type the function expects. When defining multiple parameters, separate the parameter declarations with commas like this. Yeah, right. So x and so y and 7 and 2, and I xy is x and the xy. Okay, and run the program, and I pass 7 and 2 separately, and x equals 7, y equals 2 in the scope, and the value of xy is 7 and 2 respectively, so that's okay. And this example creates a function named print labeled measurement with 2 parameters, so 5 and so h, and so I32 and char, and the value is equals 5, and unit label has h. Okay, and it's type char the function, then prints text containing both value and the unit label. Let's try running this. Go replace the program country, blah blah blah. Right, so, and I change the type char, y to be char. I changed the type, then argument, and then 7 and h. Okay, and because we call a function with value blah blah blah. Yeah. Statements and expressions. Functions bodies are made up of a series of statements, optionally ending in an expression. What? Made a series of statements, yeah, and optionally ending in an expression. Okay. So far, the functions we've covered hasn't included an ending expression, right? So return in other languages, maybe. But you have seen an expression as part of a statement, because Rust is an expression-based language. Rust is basically a functional based language, and also Rust is an expression based language. So I so I so I've seen if expression if expression if expression instead of saying like so if statement usually so as usual I I use in other languages because Rust is an expression-based language. This is an important distinction to understand. Yeah, other languages don't have the same distinctions. So let's look at what statements and expressions are and how their differences affect the bodies of functions. Statements are instructions that perform some action and don't return a value. Don't return a value. So like if statement for statement, don't return any value, but expressions vary to a resultant value. Okay, let's look at some examples. We have actually already used statements and expressions creating a variable and assigning a value to it with the let keyword is a statement. In listing 3.1, let x equals 6 is a statement. File name src main rs. And so if let x equals 6 and function definitions are also statements. The entire preceding example is a statement in itself, as we'll see blah blah blah. As we'll see below, calling a function is not a statement. Calling a function is not a statement, though. Statements don't return values. Statements don't return values. Therefore, you can't assign let statement to another variable. As the foreign code tries to do, you get an error. Yeah, this is statements and there's no output, there's no return values. So let x equals nothing. When you run this program, the error you get looks like this. Comparing function parameter expected expression. So let x equals expression. That's okay. So let's keyword expects this type of declaration expects expression, so meaning the result value, return value of expression over an expression, you know. Only supported directory in conditions of if and while expressions. So I I I think so. Let x equals if. Can I do that? Oh, sorry, typo. 5. What? Missing else. What? What? Can I do that? Cargo build. Well, okay, unnecessary parentheses. Uh, okay, unnecessary parentheses. Cargo run 5 because always true and return the expression. What? That's very interesting. So if expression is like this. Wow. When you run through blah 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 and worry about it. Array with these parentheses. And assign unnecessary parentheses. Yeah, okay. Let y equals 6, 7 doesn't return a value, so there isn't anything for x to bind to. It is different from what happens in other languages such as C and Ruby, where the assignment returns the value of the assignment. In those languages, you can write x equals y equals 6 and have both x and y have the value 6. That is not the case in Rust. Okay, so y equals z equals 10. Oh, comparator. Oh, let's. Okay. But however, this doesn't work. So and in Rust expressions vary and make up most of the rest of the code that you write in Rust. Consider math operations such as 5.6, which is an expression. Yeah, right. So as I wrote, 5 is as an expression, and so as this says 5 plus 3 should be 8 and return, right? So it's equivalent to return the value 8. So right, so the value is 8. Yeah. Everything. So this is expression. Just 5, 4, 4, 4. This is expression. And if blah blah blah, this is also expression. But this is not expression. This is a statement. I get it. Expressions can be part of statements. Okay. Lesson 3.1 and 6.7 is an expression. So 6 is an expression that evaluates to the value 6. Calling a function is an expression. Calling a macro is an expression. A new scope block created with curly braces is an expression. For example, let y equals and scope and let x equals 3 and x plus 1, so 4. So a new scope block created with curly braces is an expression. So that's why x plus 1 returns 4, and let y this is equivalent to let y equals 4. So the value of y is 4. And I tried it myself. 4, yeah. This part is an expression to evaluate the value of 4. Yeah, this expression is a block that in this case evaluates to 4. That value gets bound to y as part of the let statement. Note that the x plus 1 line doesn't have a semicolon at the end. So doesn't have a semicolon at the end. Like Matra, you know? Have a semicolon again, which is unlike most of the lines so the behavior can change depending on the existence of the end semicolon, like so. Matrav. So when I put the semicolon to this expression, there's no output. So y equals nothing. So uh, the the compiler throws an error, so I should write this. It's work that inclusive variables blah 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 and including ending semicolons. If you add a semicolon to the end of expression, you turn it into a statement. So expression, statement, expression. Okay, and it'll then not return value. Keep this in mind as you export function return values and expressions. Next, functions with return values. Functions can return values to the code that codes them. We don't name return values, but we must declare their type after an arrow. So return value. Okay, for example, test, not test, add, and x I32 and y I32, and the return value should be I32, and so x plus y. Maybe it's a return x plus y, but just writing x plus y is enough. Maybe because this is expression and returns it the expect x plus x and y, and add these values and return the result, and so I explicitly specify the return type as I32, like so. Let now add 5 4 no 4 3 4 3, and I accept 7 as let x no let result equals add 4 3, and I expect 7, and I run the code, and 4 3 and 4 3, and x is 4 and y equals 3 in the scope, and add to 7 and return the and this line evaluates to 7 and return 7 with I32 type, and I print the result, and the output of y is 7 as I expected. That's okay. And in Rust, the return value of the function is synonymous with the value of the final expression in the block of the body of the function. You can return array from a function by using the return keyword and specifying the value. But most functions return the last expression implicitly. Here's an example of a function that returns what? Okay, it returns the last expression implicitly. Okay. fn5 and return type is I32 and 5, and this will return 5 with I32 type. And if remain, this is enter point, let x equals 5 and call the function, and x equals 5. Yeah, and the value of x is 5. There are no function calls, macros, or even let 75 function, just a number 5 by itself, but just the number, this 5 is an expression. That's a perfectly valid function in Rust. Note that the function's return type is specified to as like arrow operator, and I thought to try running this code, the output should look like this. 5 in 5 is the function's return value, which is why the return type is I32. Let's examine this in more detail. There are two important bits. First, the line let x equals 5 shows that we are using the return variable function to initialize a variable, because the function 5 returns a 5. That line is the same as the foreign. Well, let's examine this thing already. There are two variables. The second, the 5 function has no parameters and defines the type of the return value, but the body of the function is a lonely 5 is no semicolon, because it's an expression whose value we want to return. Let's look at another example. Press 1, 5, 5, press 1, and return the value. So the value of x is 6. Yeah, running this code will print the value of x is 6, but if we place our semicolon at the end of the line containing x plus 1, there's no result. There's no return. Changing it from an expression to a statement, we'll get an error. Okay. Comparing this code produces an error as follows. Our information with blah 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 blah. Mismatched types. Expected I32, but found unit. Implicit tree returns it as its body has no tail return expression. Okay. The main error message mismatched types reveals the core issue with this code. The definition of the function +1 says that it will return and I32 bad statements don't evaluate to a value, which is expressed via the unit type. Therefore, nothing is returned, which contradicts the function definition and results in an error. In this output, Rust provides a message to possibly help rectify this issue. It suggests removing the semicolon, which would fix the error. Okay, I understood. And comments: our programmers strive to make their code easy to understand, but sometimes extra explanation is warranted. In this case, programmers leave comments in the source code that the compiler will ignore, but people reading the source code may find useful. Here's a simple comment. Yeah, double slash is a very common way to describe write comments. In Rust, the idiomatic comments that starts a comment with 2 slashes, and the comment continues until the end of the line. For comments that extend beyond a single line, you need to include double slash on each line like this. So we are doing something complicated here, long enough that we blah blah blah. And comments can also be placed at the end of lines containing code. Yeah. I will more often see them used in this format with the comment on a separate line above the code is annotating. Yeah, so I often use, yeah, I have to write comment. Yeah. Alright, Rust also has another kind of comment document, blah blah blah, and also multiple line comments like this, or just a single line, and yeah, that's enough to understand how to write comments. And next, control flow. This is the last section of the third chapter. Oh, it's over 2 hours, and I'm getting tired. This is the last part. Yeah. and the ability to run some code depending on whether a condition is true, and to run some code repeatedly while a condition is true are basic building blocks in most programming languages. The most common constructs that let you control the flow of execution of Rust code are if expressions and loops. If expression, loop expression, yeah. If expressions, and if expression allows you to allows you to branch your code depending on conditions. You provide a condition and then state if this condition is met, run this block of code. If the condition is not met, don't run this block of code. Create a new project code branches in your project to actually to explore the if expression in the blah blah blah. And there's no parentheses actually, but the only difference between Rust and other languages is this, maybe if and else if, and yeah, this is very common way to write the if statement. This is very, yeah, common syntax. Now number, let number equal 3, and if number is less than 5, so that's true, and condition was true, and the code uh, output condition was true, yeah. Or if expression start with the keyword f followed by a condition, in this case the condition checks whether or not the variable number has a value less than 5, we press the block of code to execute if the condition is true. Immediately after the condition inside curly brackets, blocks of code associated with the conditions in if expressions are sometimes called arms. Okay? Just like the arms in match expressions that we discuss in the blah 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 section of chapter 2. Arms, okay. Optionally, we can also include an else expression, which we chose to do here to give the program an alternative block of code to execute should the condition evaluate to false. If you don't provide an else expression and the condition is false, the program will just skip the if block and move on to the next bit of code. Try running this code. You should see the following output. Cargo run. Cargo run. Oh, sorry. Value of what? What? Oh, I didn't save. Condition was true, and if I turn it in, change the value into 7. 7 is obviously, yeah, greater than 5, so I expect the line. I cargo run and condition was false, and this is okay. And let's try to change the valid number to valid maximum. Yeah, or I already done that. It's also worth nothing that the condition in this code must be a bool. If the condition isn't a bool, we get an error. For example, try running code. Yeah, type mismatch. Executed bool, found integer. Not executed, expected bool, found integer. The state condition evaluates the value of 3, this time Rust was an error. The error indicates that Rust expected a bool but got an integer. Unlike languages such as Ruby and JavaScript, Rust will not automatically try to convert non-Boolean types to Boolean. So implicit conversion, implicit change doesn't occur in Rust. Rust is not the case. you must be explicit and always provide if with a boolean as its condition. If we want the if code block to run only when a number is not equal to 0. For example, we can change the if expression to the following: let number equals 3 if number isn't the same as 0, so which is true, the number is something other than 0. Yeah, running this code we print number was something other than 0. Handling multiple conditions with else if, we can use multiple conditions by combining if and else in an else if expression. For example, uh, let number equals 6 if number percent 4 equals 0, number is divisible by 4, and 3 to else. The program has for possible paths, so paths is so arms it can take. After running it, you should see the following output. So 6 is a number. 6 isn't divisible by 4, but 6 is divisible by 3. So I expect this mine. Okay. The number is divisible by 3, and I change it into 8 and 4 and 7, and this else part is arm. And when this program executes, it checks each if expression in turn execute the first body for each the condition values is true. Note that even though 6 is divisible by 2, we don't see the output number as divisible by 2, nor do we see the number blah 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 is broke. That's because Rust only executes the block for the first true condition. Yeah, this is important. And once it finds one, it doesn't even check the rest. This is exactly the same as in other languages. Using too many else if expressions can clutter your code. Yeah, like so. That's very hard to read, difficult to read. So if you have more than one, you might want to refactor your code. Chapter 6 describes powerful Rust branching construct code match. For these cases, match expression using if let statement. Oh, I darn I did it in the last section, maybe. Using if in a let statement, because if is an expression we can use it on the right side. Well, let's say to assign the outcome to a variable as in lesson 3.2. Let condition equals true, let number equals if condition. So true, in this case condition is true, so 5 will be stored into the number, so the value of number is 5. Yeah, the number variable will be bound to a value based on the outcome of the if expression. Run this code to see what happens. Remember that blocks of code evaluate to the last expression in them, and numbers by themselves are also expressions. In this case, the value of the whole if expression depends on which blocks of code executes. This means the values that have the potential to be results from each arm of the if must be the same type. In listing 3.2, the result of both if arm and the else arm were isolated integers. If the types are mismatched, as in the following example, we'll get an error. And this syntax is a little similar to kind of this how can I call that? How can I call this? But so three blah, blah, operator blah, 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 ternary operator, yeah, ternary operator, yeah, this uh, the order was different. And Chicago run, Chicago sorry, Chicago run, and the variable number is 5. Yeah, remember that blocks of code vary to the last expression, then the numbers by themselves are also expression. In this case, a variable of the whole if expression depends on which blocks of code execute. This means a value that have the potential to I I read that part, sorry. When we try to compile this code, we'll get an error if the blah blah blah. what 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 06 number not found in this scope. what what expected integer found on SDR. So the expression in the if block statements to an integer and the expression in the else blocks evaluates the string. This won't work because variables must have a single type, okay? And Rust needs to know at compile time what type the number variable is definitively, and knowing the type of number lets the compiler verify the type is valid everywhere. We use number. Rust wouldn't be able to do that if the type of number was only determined at runtime. The compiler would be more complex and it would make fewer guarantees about the code if it had to keep track of multiple hypothetical types for any variable. Repetition with loops. It's often useful to execute a block of code more than once. For this, Rust provides several loops which will run through the code inside a loop body to the end and then start immediately back at the beginning. To experiment with loops, let's make a new project called loops. Sorry. My headset's battery is getting lower. I'm about to speed up. Repeating code with loop. The loop keyword tells Rust to execute a block of code over and over again, forever or until you explicitly tell it to stop for the the loops actually to loop. This is infinite loop. When we run this program, we will see again print over and over continuously until we stop the program manually by typing Ctrl+C again, and when I type this Ctrl+C, I can stop the code. And we stop the program manually. Most terminals support the keyboard should the Ctrl+C to interrupt the program that is stuck in a continual loop. Give it a try. Okay. You may or may not see the word again printed after depending on whether the code was in the loop when to receive the interrupt signal. Fortunately, Rust also provides a way to break out the loop using code. You can press the break keyword. Yes, like my counter equals 0. And let's result equal sorry, let result equals loop and counter plus equal 1, and if sorry, counter equals 0, break counter times 2. Okay. and the result is result. What? Oh, sorry. Cargo run, and the result is 20. So counter is initialized as 0, and one plus, and once counter reaches 10, and break and return the value of 20, and it stores this loop expression evaluates the value of 20 and results towards 20, and the result is 20, and see I can see the output. Yeah, before the loop, we declare a variable named counter and initialize it to 0, and then we declare a variable named result to hold the value returned from the loop on every iteration of the loop. We had 1 to increment the counter. The counter is once the counter is reached, whether the counter is whether the counter is equal to 10. When it is, we use a break it. So break the keyword and return the value of the 10 plus, no, 10 times 2 equals 20. So which is in the case is 20. Yeah. You can also return from inside the loop, while break only exits the current loop. Return always exits the current function. Loop travels to disambiguate between multiple loops. Okay. If you have loops within break and continue apply to the intermost loop, the most internal loop. Yeah, you can optionally specify a loop level on a loop that you can then use the break or continue to specify that those keywords apply to the level loop instead of the intermost loop. Loop levels must begin with a single quote. Here's an example with two nested loops. Loop and